Welcome back to Linear Circuits. This is Dr. Ferry. We're going to be doing a lab demo, which is a follow-on to the previous demo that we did. Now we're going to build basic circuits. Let's go ahead and remind you of the basic resistor configurations. We've got the series and parallel. In the series, remember, you add them up. In the parallel, if we've got two resistors, it's the product over the sum. So I want to first build two resistors in series with one another. And remember how this breadboard works. If I want to connect two things, I have to put them in the same row. So if I put this resistor right here, then the other resistor has to be in that center row the same. So I could put it over to here, or I could have put this end down over here. So let's go ahead and measure this resistance. I'm going to change this scale to 20K because I've got a 1K and a 2K together. I should get 3K. I'm going to put my leads in the same holes, but and barely hold them up there just so it's snug. 2.96K. So it's close to 3K. It's within tolerance. And actually, let's move around a little bit. Yeah, 2.96. If I want to put these in parallel, then I'm going to swing one of these back around so that I've got to have them in the same nodes, same rows on both ends. Now let me go ahead and measure this. And 1K and 2K, let's see, let me show you what we measure. We're going to get 0.65. If I want more resolution, I can go down on my scale there. So I'm measuring close to 660 ohms right here. And what should it be? Well, it's the product over the sum. I've got a 2K and a 1K. So I'd have a 2K times a 1K over 3K, and that's about 666 ohms. Now, what I'd like to do is actually build a circuit. Let's build a series circuit. And I'm going to add my battery in there as my power source. And let me make a connection between my resistors and the rows that I'm going to put the battery into. So then I put the battery into this set of rows. What we're going to want to do is look at the voltage divider law. So when we've got resistors in series like this, then V2 is a voltage across one of the resistors, is that resistor over the sum of the two resistors times the voltage source. So in this circuit, I've got the two resistors in series. If I want to find the voltage across one of them, I have to find this resistance over this sum times this voltage. So if I look at this, I need to put this back into the voltage, and what we've already measured over here. This is a positive, that's a negative. 4.76 is the voltage source. What's the voltage over here? Is 3.17. Where does that come from? Well, this is the 2K, and so it's 2,000 over 3,000. So in other words, 2/3 of the voltage source here. Next, we're going to want to measure current. There's actually two ways to measure current. One is with the ammeter that's available on the DMM, and the other is to use Ohm's law, where we would measure the voltage across one of our resistors and then just use Ohm's law to find the current. So we'd take that voltage divided by that resistance. Going back to the circuit that we've built, we want to measure this current. So what I can do is measure the voltage across one of the resistors and then divide by that resistance. So right there, that's 1.57 volts, and this is a 1K resistor, so it would be 1.57 divided by 1,000 would be 1.57 milliamps. Now the other way to measure it is to have to break up this circuit. I'm going to break up the circuit right here. So if I move one of these resistors into another hole, I now have an open circuit right there. And actually, you can test that open circuit by seeing how much voltage drop is across this. We get 0 voltage drop means there's 0 current. So the ammeter has to be in series with the circuit. So if I change this to the ammeter, I'm going to be expecting a very small amount of current. And I put this in series. And I get just about the same thing, 1.59 milliamps. Now notice if I reverse the polarity on this, it's equivalent to changing the direction of my current, and I'm going to negate it right there. To summarize, let's look at our key concepts that we've gone through in this lab demo. We showed how to connect physical resistors in both parallel and in series. We've shown how you can measure voltages and currents and how you can actually build the circuit, and how you can use the voltage divider law and Ohm's law. And finally, we showed how to measure current in 2 ways. One is with the ammeter, where the ammeter has to be in series with the circuit, and the other is using Ohm's law, where we measure the voltage across a resistor and then use Ohm's law to find the current. All right, thank you very much.